So preparing for the Chapter 3 test, lots of factoring. So for these first two problems, we will be doing trinomial factoring. So I should see steps, and I should see the factored form. But if you use trinomial factoring and want to use this kind of format, what multiplies to 21 adds to 10. The trinomial x over here, that blue, is optional in terms of showing your work, but I do need to see the stuff that's done in red. Right, so I'm looking for factor pairs of 21 that also add to the 10. Right, so what can I add to make 10? Multiply to make 21. That would be 7 and 3. So my factor pair that I'm going to use to factor x squared plus 10x plus 21 is the 7 and the 3. So x plus 7 times x plus 3. And then I would split this into two problems. So x plus 7 equals 0. And x plus 3 equals 0. And then I would solve those two equations. So I'm going to subtract 7 away. X equals -7. Here, I would subtract the 3 away. X equals negative. So my answer is x equals -3 and x equals -7. For number 2, right, what multiplies to 7 adds to -8. So I would need to use that to double negative factor pair so that I can get a negative value, the negative b value. So x minus 7 times x minus 1 equals 0. And then I split. And I solve those two equations. So I get x equals 7. Or x equals 1. Same for number 3. Factor pairs. Right, I know that it's going to be x times x. And then to get this negative here, I'm going to need one negative, one positive. So I am going to use the factor pair of -6 and +2, because those would add then to the -4 here in the middle that I need. So I split. And I solve those two. So I would add 6 away here, get x equals 6. I subtract away the 2 here, so we get x, so -2. So my answer here, -2 and 6. Number 4 is a greatest common factor problem, GCF. Because there's no c value, no constant out at the end, I can only divide x out of both terms, right? X squared divided by x is just x. -9x divided by x is -9, which means leave me with x times the quantity x minus 9 equals 0. And then I would split that and solve just this right equation here. Add away that 9. So my solution is 0 and for number 5, we need a -12, right? And a +1. There's +1 right here. So I'm going to go with +4. And -3 is my factor pair because they multiply to -12. And they also add to the +1. So when I split that, I get x plus 4 equals 0. X minus 3 equals 0. And then I would solve those two equations. X equals negative 4. X equals positive 3. For number 6, we could go with the difference of squares, right? That is the concept of a squared minus b squared equals 0. And then that would tell us that we can factor that into a plus b times a minus b. So I can see here I have x to the second power is x squared, and 7 squared is 49. So then I can factor that out into x plus 7 times x minus 7. You could also just go with trinomial factoring here. What multiplies to negative 49? There's technically a 0x here in the middle. So that would be negative 7 and positive 7 cancel out to make the 0. Either way, you're going to get to the same spot. So then I would set this equal to 0, and I split to factorings. So then when I solve those, I get x equals negative 7 and x equals 7. For the next 4, we're dealing with simplifying with the imaginary unit. So remembering that the powers of I repeat every 4 powers. So to simplify I to the 10th, I'm going to take that exponent of 10 and I'm going to divide it by 4. And all I really care about is the remainder, right? So I get 2 remainder 2. So I to the 10th is the exact same thing as I squared, right? That remainder becomes my new exponent. And then we know that I squared is the same as negative 1. For 8 and 9, we're just doing combining like terms, right? So I'm going to combine the 3 and the negative 10 to get negative 7. I'm going to go negative 9i minus 7i for negative 16i. Similarly, for number 9, 4 minus a negative 8 would be negative 4. Then the negative 2i, and then I'm subtracting a 5i would be negative 7i. And that is all you're doing for 8 and 9 is just combining like terms. For number 10, I'm going to work number 10 up here because we need to FOIL these factored pairs, right? So we're going to FOIL to do multiply 2 minus 7i times 5 plus 7i. So first terms would be here. 2 times 5 is 10. My outside would be these two. So 2 times 7i would be a positive 14i. Inside terms would be these. Let's go zigzag here. Right, so negative 7i times 5 would be negative 35i. And then my last terms would be the negative 7i times 7i. So negative 7 times 7 is negative 49, and I times I would be I squared. We have a lot of simplifying left to do. Some combined like terms here in the middle. So 14i minus 35i would be negative 21i. And for the negative 49i squared, well, I squared is the same as negative 1. So we get 10 minus 21i plus 49, because negative 49 times negative 1 is positive 49. And then I would do one last combine like terms on the 10 and the 49 for a final answer of 59 minus 21i. For 11 and 12, we're solving for x. These answers will contain the imaginary. So we use our normal solving strategy, right? Please excuse my dear Aunt Sally, right? The 4 steps to order of operations. When we solve, we go backwards. Right? So we're going to go this way. We're going to remove any addition or subtraction. So, right, I would start by subtracting that 24 away. To get 6x squared equals negative 24. I would then divide away the 6 from both sides. So I get x squared equals negative 4. Last part of the solving would be to get rid of the exponent. So I undo a square by taking the square root of both sides. Square root of negative 4. So I need to factor out the negative 1 times 4. So square root of the 4 would be plus or minus 2. And the square root of negative 1 is I for the imaginary, right? Because in the real number set, there is no number for square root of negative 1. For number 12, we're going to subtract away the 25. So I get x squared equals negative 25. Square root of both sides. Again, square root of negative 25, I need to separate out the negative 1 from the 25. Square root of the negative 1 is I, and the square root of 25 is plus or minus 5. For 13 through 16, we have our choice of completing the square using quadratic formula. The important thing there is if you want all the credit, you got to show work. You can't just write down answers. So looking at 13, if you wanted to use quadratic for this, you could. But remember, when you're using the quadratic formula, you have to have a quadratic equals 0. And 13, you have equals 25 on the right side. So you would have to subtract that 25 away. At that point, you could actually use trinomial factoring. What they want you to do for this problem is use the complete the square strategy. So let's look at that strategy for number 13. Looking at that, we already have a perfect square set up on the left side, right? And 25 also happens to be a perfect square. So looking at 16, what can I multiply to 16 and add to negative 8, right? So that would be negative 4 and negative 4, right? Because these two factors, because the factor pairs are is the same number, right? I'm going to have x minus 4 times x minus 4, which I could then simplify to x minus 4 squared. To solve out from there, you would take the square root of both sides, right? So the square root of 25 is plus or minus 5. A common mistake is to forget about the plus minus. We need that because typically parabolas look like this, and if we are looking for a point of intersection, it could be very well crossing here 2 points. That plus or minus is what gives us the potential for having 2 solution points. So I would separate this out into x minus 4 equals 5 and x minus 4 equals negative 5. Right from there, I solve it up. I get x equals 9. And over here, I get x equals negative 1. For 14, you could go with complete the square. I would probably just go with quadratic formula, right? So my a value, my b value, and my c value, and then I would plug those in, right? X equals, and I would fill in all my a's, b's, and c's. I use a lot of parentheses, especially in that first step, just so that I don't miss any signs. So negative b plus or minus square root of b squared. Right, my b value is negative 10. Why I'm making sure I pay attention to those parentheses. Minus 4 times a times c. And I'm going to pop over to this part of the screen here. X equals. And then my new denominator is just going to be 2. The opposite of negative 10 is 10. Plus or minus square root of, well, negative 10 squared is 100. And negative 4 times 1 times 7 is negative 28. So now I'm at simplifying underneath the square root. Right? 10 plus or minus square root of 72 all over 2. Now, square root of 72. 72 is not a perfect square. So we need to factor that out into a perfect square times another factor. So we're looking for factor pairs of 72, where one of them is a perfect square. And a lot of people go to 9 times 8 because 9 is a perfect square. It's probably the most common thought of factor pairs of 72, other than 1 and 72. But 8 also contains perfect square. The largest perfect square that is a factor of 72 is 36, right? So 36 times 2 is the same as 72. So when I factor that, I want to use that 36 times 2. So I get 10 plus minus square root of 36 is 6. And then square root of 2 is just going to stay 2. One last step would be to divide both the terms up top by 2. So 10 divided by 2 is 5, plus or minus 6 divided by 2 is 3, and then square roots of 2. And then we will leave that answer in that format. We are not going to plug that into a calculator. Definitely going to go with quadratic formula here. So label my A, my B, my C. Difference here is we have an A value other than 1, which is fine. We just have a little bit more multiplying to do. Right? So my denominator is going to be 2 times 3. The numerator is negative 12 plus or minus the square root of 12 squared minus 4 times A times C. So simplifying here, it's 6 on the denominator, negative 12 plus or minus 12 squared is 144. And then negative 4 times 3 times 15, probably calculator work, would be negative 180. Just keep simplifying away. Number be negative 12 plus or minus the square root of negative 36 all over 6. So we have an imaginary here because we have a negative under the square root. right? So we're going to have negative 12 plus or minus. Now the square root of 36 is 6, and the square root of the negative then is I, all over 6. One last simplifying, because we can divide top and bottom, or both terms up top by the denominator of 6. So I get negative 2 plus or minus I, right? Because negative 12 divided by 6 is negative 2. Plus or minus 6i divided by 6 is plus or minus I. For 16, we could subtract the 6 away to the left side so that it equals 0 on the right side. Or we could try to complete the square, right? So x squared plus 2x plus something is equal to 6 plus whatever it is we decide to add to the left side. To determine what we are going to add to complete the square, we take this b value, and we go b over 2 squared. That's what will give us a perfect square on the left side. So that would be 2 over 2 all squared. Well, 2 divided by 2 is 1, and 1 squared is equal to 1. So what we add to both sides is 1. So just separate here. I am going to get a perfect square is equal to 7. My perfect square is going to be x plus, and then this value here, before I square it, is what goes in parentheses, which also happens to be 1. It gets a little weird on this one because they're both 1s. That's because 1 squared is still 1. So now I'm left with x plus 1 all squared equals 7. That allows me to take the square root of both sides. X plus 1 equals square root of 7. Right over here, I took the square root of both sides to work to isolate x. Right? We have to remove the square before I can deal with the x plus 1 under in the parentheses. So square root of 7 is as simplified as it's going to get. So then I would need to subtract away this 1. X equals square root 7 minus 1. The best way to rewrite this would be the negative 1 out front, and then the square root of anything is going to be plus minus. So it would be negative 1 plus minus square root of 7. So those are a lot of work. I don't think it's necessarily difficult work, just lots of order of operations work. So when we are trying to look at some inequalities involving parabolas or quadratics, and we're trying to solve those graphically, right, we can use our graphing calculator to help us get the graph that we need. Right, so if I just press graph after I've entered the equation, looking for a vertex, looks like my vertex is somewhere between -2 and -3 on the x-axis, and then just below the x-axis, so maybe negative some decimal number between 0 and 1. So looking for points that I can graph, I am going to make a data table. X, Y. Right, and I see symmetry in my data here. Right, now this is all coming from my table on my graphing calculator screen. Right, I see zeros in the Y column. I see 2s in the Y column. Right, I see 6s in the Y column. What I don't see is the vertex. So I can assume that my vertex is at negative 2.5, and then something that is just slightly negative for Y. I'm just going to go ahead and graph what I have, right? So I know my vertex is between these 2 points here. And then I'm going to graph my other 2 that will fit on the grid that is provided. Right, I know my vertex is somewhere down here. When I am graphing inequalities, I have to decide if I am using a solid line or a dashed line. So greater than or less than, get a dashed line. My or equal tos, get a solid line, right? So line underneath the inequality sign, we use a solid line. So this one has the line underneath. So I'm going to graph this with a solid line. Get my pen to work. And then the other thing I have to consider is shading, right? So y is greater than this, and I represented the x squared plus 5x plus 6 with that solid line, right? So y is going to be greater than or above that line, right? So I have to pay attention to where I am going to shade. For 18, again, I'm going to enter into y equals x squared minus 3. I'm going to go to graph. I see a vertex, looks like right there on the y axis at the y-intercept. So I'm going to go to table, do a little scrolling, right? And I can then make my data table xy, right? I see a vertex here at 0, -3. Right, there's my vertex. And then I'm going to graph my other points. So graphing those points here. And here. And again, I have an or equal to in my inequality, so I am going to use a solid line to graph. And then y is less than or equal to the line, right? So I'm going to be shading below the line. For my last 2, I'm going to be solving these inequalities algebraically. So I need to find my intercepts. Right, I'm going to, for a moment, pretend that this is an equation, not an inequality. So I am going to work to solve x squared minus 10x plus 21 equals 0, right? Because I need to find my x-intercepts, right? So I'm going to factor this like I would a quadratic equation, right? So I'm going to get x plus or x minus 7 times x minus 3 to get the -7 times -3 gives me the positive 21. -7 minus 3 gives me the -10. So I'm going to get solutions at x equals 7 and x equals 3. I am going to plot those then on a number line, right? And I'm only just worried about 3 and the 7 for now, right? But remember, this is a number line. What I'm trying to figure out is where the valid part of this is. So I'm trying to figure out, is this the valid part of my graph, right, where the graph is less than 0? Or is this part here in the middle the valid part of my graph? And in order to do that, I really need to check at least one value. Because what I end up with is, I end up with 2 options. If so my number line can, pen does not want to cooperate, right? I can have where I have valid solution in the middle, or I can end up where I have valid solution on the outside parts. So I have invalid here, and I have valid on the outside. Check mark does not want to show up here. But you would get the outside parts of my number line be the valid solution. So the easiest point to check is 0. So I put 0 where it belongs on the number line, which would be right there, right on the left side of the number line. Because up here, 0 squared is 0, negative 10 times 0 is 0. So that leaves me with 21 less than 0. So I'm checking validity. Is that a valid, true statement? And it is not, right? So the outside parts have to match. So that was invalid out there, meaning my valid part is in the middle. And if I subbed in, and you don't have to do this, if I subbed in a 5 here, I would get 5 squared is 25 minus 10 times 5, which is 50, plus 21 less than 0. And if I simplified that, I would get negative 4 less than 0. And that is a true statement, right? So this is the valid part of the graph. And I need to write this as an inequality, right? So I know that x is between the 3 and the 7, right? So I'm going to put the inequality 3 less than x less than 7, meaning x is between 3 and 7. And I chose the signs without the or equal to line because my inequality symbol in my original problem does not contain the or equal to. I'm going to do the same thing here in 20. I'm going to factor x squared plus x minus 30, right? And to do that, I'm just going to use trinomial factoring to find those roots or solutions. So I'm going to get x plus 6 times x minus 5, right? Because negative 30 can be made by a lot of different factor pairs, but I need one that adds to 1. So it would be 6 and negative 5, which gives me solutions at x equals negative 6 and x equals 5. So I plot those on my number line, negative 6 and 5. And I'm trying to figure out where the valid part is. Is it in the middle? Or is it the two outside pieces? I'm going to check 0. So 0 falls in the middle, right between the negative 6 and the positive 5. So 0 squared is still 0 times plus 1 times 0, which is still 0. So that leaves me with the negative 30 greater than 0. Is that a true statement? No, that is a false statement. So if the false is in the middle, the true parts have to be on the outside. So I'm going to finish by writing that as an inequality. X is less than negative 6, right? This is valid going this way. It would be an open circle here, right? An open circle here going this way. And I know they're open circles because this does not contain the or equal to sign, right? So x is less than negative 6, or x can be greater than 5. I know those are kind of a lot of work, but we factor, just like it was an equation here, we graph them on a number line, and then we check validity. So that is the review for the